Good morning all. Let's continue with the maths, grade 11, chapter 8, chapter name sequences and series. Today we are going to learn geometric progression. Let us consider a geometric progression with first non-zero term as a and the common ratio as a r. Okay, when we write this terms of it, okay, we will be obtaining the second term by multiplying the first term with r. And this, therefore, the second term will be noted as a a2, that is equals to ar. Similarly, third term is obtained by multiplying a2 by r, means second term with the r, that will be third term. Therefore, a3 will be a2 into r, that is ar square. For example, here, if first term is a, then we are multiplying the first term with the common ratio r. This is the second term. Next, when we are multiplying second term again with the r, so it will be a r square. Like that, this will be a r cube. So we can write it as a till a r power n. Therefore, the pattern suggests the nth term of a geometric progression. If this is the first term, this is second term, and will be keep on. This is nth term, a into r power n minus 1. Thus, a geometric progression can be written as ar square, ar cube, ar power n minus 1. Okay. Here, ar square will be according to a geometric progression is finite or infinite. Here, when we say the finite, the terms will be limited. Infinite terms will be keep on continuing. So, this is an example for the finite. This is for this infinite. Sum of n terms of a GP. How we are going to calculate is, first we will assume this first term of a GP is a and the common ratio is r. Now let us notate sum of n terms of a GP as a Sn, that is the first n terms of a GP. Then we will write as Sn is equals to a plus ar plus ar square, so on. This is the nth term, ar power n minus 1. Now, case 1, if r equals to 1, if we substitute r as a 1, then all terms will be a, like that. So, it will be like n terms, n terms. So, n into a. Therefore, if r is equals to 1, sum of this geometric progression will be na. If r is not equals to 1, then let us multiply this first equation with this 1. Then with r, then it will become r into Sn is equals to, then the first term will become ar, second term will be ar square, so on till ar power n. Now, let us subtract 2 from 1. So, if we subtract, then we are going to get as 1 minus r into Sn is equals to a minus ar power n. If we take a common here, we are going to get a into 1 minus r power n. Then we can write as Sn is equals to, by transposing 1 by r to this one, we are going to get as a into r power n minus 1 divided by r minus 1. For example, here Sn is equals to a into 1 minus r power n divided by 1 minus r if r is less than 1. If this ratio, this one is less than 1, we will be writing 1 as a first. If r is greater than 1, then we will be writing Sn is equals to a into r power n minus 1 divided by r minus 1. Let us solve exercise 8.2. First question. Find the 20th and nth terms of a GP 5 by 2, 5 by 4, 5 by 8, so on. Here, solution. First, given GP is 5 by 2, 5 by 4, 5 by 8. We know that nth term is an is equals to a into r power n minus 1, where a is the first term and n is the number of terms and r is the common ratio. So here a first term is 5 by 2, then r is equals to 1 by 2. Let us substitute these A and R in this formula. An is equals to A into R power n minus. Here, the first case, here 20th term. So, 20th term is n is equals to 20. So, 20th term of a GP is equals to 5 by 2. Here is A into R power 20 minus 1. A R power 19. So here let us substitute A as a 5 by 2 and R as a 1 by 2, 20 minus 1, that is 19. This will be 5 divided by 2 power 20. Here 2 power 19 into 2 power 1 is 2 power 20. Therefore, 20th term is 5 by 2 power 20. Nth term of a GP. Nth term is An is equals to A into 1 R power n minus 1. So here 5 by 2 into 1 by 2 whole power n minus 1, that is 5 divided by 2 power n. Let us solve question number 2. Find the 12th term of a GP whose 8th term is 192 and the common ratio is 2. Solution. 8th term of a GP is 192 and R is equals to 2. We know that nth term of a GP is An is equals to A into R power n minus 1, where A is the first term and n is the number of terms and R is the common ratio. Given that here 8th term is 192. So A8 is equals to A into R power 8 minus 1, that is 192 is equals to A into, here R is 2. So 2 power 7. Now A will be equal to 192 divided by 2 power 7. Therefore 12th term of a GP is equals to, here in place of A we will substitute 192 divided by 2 power 7 into 2 power 12 minus 1, that is 192 into 2 power 4, because here 2 power 11 will be there. 2 power 11 divided by 2 power 7 is 2 power 4, because A power m divided by A power n is equals to A power m minus n. So here 2 power 11 divided by 2 power 7 is equals to 2 power 11 minus 7, that is 2 power 4. Therefore the value is here 192 into 2 power 4. 2 power 4 is 16. Therefore 192 into 16 is 3072. Therefore 12th term of a GP is 3072. Let us solve question number 3. The 5th, 8th and 11th terms of a GP are P, Q, S respectively. We need to show that Q square is equals to PS. Solution. Given 5th, 8th and 11th term of GP are P, Q and S respectively. Therefore, we need to prove Q square is equals to PS. Proof. So, nth term of a GP with the first term as a and a common ratio as R is An is equals to A into R power n minus 1. So, here 5th term of a GP is A5, that is equals to A into R power 5 minus 1, that is A R power 4, that is equals to P. Let us make this as a equation 1. Let's 8th term of this GP is A8, that is equals to A into R power 8 minus 1, that is A R power 7. Let us assume that is a Q, because here they have given the terms, right? 5th term is P, 8th term is Q. So now let us find 11th term. 11th term of a GP is A11, that is A into R power 11 minus 1, that is A R power 10, that is yes, as per the given statement. From 1, 2 and 3, we can write it as here Q square. Q square is A square R power 14, because 7 square will be 14. So A square into R power 14. Let us multiply equation 1, 3, that will be P into S is equals to A power A into R power 4 into A into R power 10, that is A into A is A square, R power 4 into R power 10 is equals to R power 14, because A power m into A power n is equals to A power m plus n. Therefore, R power 4 into R power 10 is equals to R power 14. So, by observing these two terms, both are equal. So, we can conclude that Q square is equals to PS. Hence, proved. That's what we need to require. Let us solve question number 4. The fourth term of a GP is square of its second term. And the first term is minus 3, determine seventh term. So here, given the fourth term of a GP is square of second term. Let us assume the GP, the second term, the first term. And here the first term is minus 3. So we need to find seventh term solution. So fourth term of a GP is square of second term. The first term is 3. So fourth term of GP is A4, that is A r power 4 minus 1, that is A r cube. Let us note it, this is equation 1. And second term is A2, that is A r power 2 minus 1, that is equals to AR. And here it's given that fourth term of a GP is equal to square of its second term. So A r power cube is equals to A r cube is equals to A r whole square. That is, now we can write it as A r cube is equals to A square r square. This one, this 2 r square, and here we can cancel, and we can cancel, A in the term here we can cancel. Therefore, we are going to get r is equals to A. This implies A is equals to r is equals to minus 3, because first term is minus 3. This is nothing but A is equals to minus 3. As A is equals to r, it implies r is also minus 3. Therefore, seventh term is equals to A into r power 6. Substituting A as a minus 3 and r as a minus 3, we are going to get minus 3 into minus 3 power 6. Therefore, seventh term is equals to, seventh term of a GP is equals to minus 2187. Let us solve question number 5. This one, A, subsection A. Which term of this following sequence 2, 2 root 2, 4 is 128? So here a GP is given. We need to find this, which term is 128. So here we need to find the value of n for which this is 128. Solution. Given series is 2, 2 root 2, 4. From this one, as first term is A2, and this r is equals to root 2. And the let nth term of a GP is 128. That is, nth term of a GP we know that A into r power n minus 1. That is equals to 128. Let us substitute A as a 2 and r as a root 2. That is 2 into root 2 power n minus 1 is equals to 128. That implies root 2 power n minus 1 is equals to 128 by 2 is 64. Here, root 2 we can write as a 2 power 1 by 2. 2 power 1 by 2 into n minus 1, that is equals to 2 power 6. Because 64 we can write it as a 2 power 6. By comparing this exponents, we are going to get as n minus 1 is equals to 6 into 2. That is, n minus 1 is equals to 12. This implies n is equals to 12 plus 1. 12 plus 1 equals to 13. Therefore, 13th term of the given sequence is 128. Let us solve 5b. Which term of the sequence root 3, 3, 3 root 3 is 729? Here, given series is root 3, 3, 3 root 3 and so on. So, the first term here is root 3, that is A is equals to root 3 and R is equals to second term divided by first term. So, 3 divided by root 3 is root 3. Therefore, R is equals to root 3. Let nth term of a GP is A into R power n minus 1, that is 729. Let us substitute R as a root 3 and A as a root 3 in this one. Then we can write it as nth term as root 3 into root 3 power n minus 1 is equals to 729. So here we can write this one as root 3 power n is equals to 729. Root 3 we can write as 3 power 1 by 2 n. 729 we can write it as 3 power 6. So here as the base is equal, so we can compare exponents, that is 3 power n by 2 is equals to 3 power 6. That implies n is equals to 6 into 2. 6 2 is 12. Therefore, n is equals to 12. Therefore, 12th term of the given sequence is 729. Let us solve 5th question, subsection C. Which term of the sequence 1 by 3, 1 by 9, 1 by 27 is 1 divided by 19,683. Solution. Given series is 1 by 3, 1 by 9 and 1 by 27. Here the first term is 1 by 3. The second term is the r is equals to 1 by 9 divided by 1 by 3, that is 1 by 3. Therefore, we know the nth term of this GP is a into r power n minus 1. Let us substitute a as a 1 by 3 and r as a 1 by 3. We know that nth term is 1 divided by 19,683. Therefore, 1 by 3 into 1 by 3 whole power n minus 1 is equals to 1 divided by 19,683. Here, 1 by 3 power n we can write it as, that is equals to 19,683 can be written as a 3 power 9. So, 1 divided by 19,683 is equals to 1 by 3 whole power 9. So, here 1 by 3 whole power n is equals to 1 by 3 power 9. As the base is same, therefore exponential this power should be equal. Therefore, n is equals to 9. Here, if you want, we can write it as a 19,683 is a 3 power 9. Therefore, n is equals to 9. Therefore, ninth term of this given sequence is 1 divided by 19,683. Thank you.